multiprocessing. Multiprocessing is the thing, is the technique where you can do multiple jobs together. So performing multiple jobs is multiprocessing or multitasking. Multitasking. It is multitasking is nothing but performing multiple tasks together. Here, when we say together, it's not parallel. Together means it is actually performing the tasks concurrently. It is not parallel execution. Parallel execution is possible only when there are multiple processors present. When there is a single processor, then multitasking is done with the help of concurrent execution, and it is done with the help of time sharing tech. This you must have come across in operating system. Now, when you take the multitasking, if you are doing multiple jobs in through multiple programs, so it is multiprocessing or multiprogramming. Multiprogramming or multiprocessing, which is performing multiple jobs through multiple programs. Means if you are doing two jobs with two different programs, it is multi-programming or multitasking. And sometimes within the same program, you need to perform multiple jobs, which is called as multi-threading. So multi-threading is the technique where you perform multiple jobs within the same program. So suppose if you are doing multiple jobs, if you have switched on the laptop, and if you are doing Word, and if you are taking the class, and if you are doing some other job, then it is multiprocessing. But within the same program, if I do multiple multiple jobs, then it is multi-threading. Like in the same program, what I'm doing is I'm able to send the text message, I'm able to send the voice message, which will be happening within the same application, which is actually the Teams application, whatever we are using. Another good application where multi-threading used is like charting program. If you take a charting program, there are multiple tasks to be performed within the same program. You need to send a message, you need to receive message. Both should happen together. Means it's not that in charting we send a message, after we send message, then get the next get message from the other party, then send message. It is not happening. While we sending a message, we may also receive. So the tasks are happening together within the same program. So it is multi-threading. So multi-threading is the technique where we perform multiple tasks within the same program. So there are so many applications currently available. Even the Teams application, whatever I'm using, it's a multi-threading based application. And also, if you take charting program, it is also multi-threading. So multi-threading is the technique where we perform multiple tasks together within the same program. Okay, that is multi-threading, definition of multi-thread. Now we'll see what is a thread. When you take program, normally when you take any program, the program gets CPU chance. So when you are performing, when you are executing, that means you have the control of CPU. When CPU's control is given to your program, then your program will have focus, and it is said to have the control, and the program is getting executed. Now, suppose if I take a control, you can take control as a big something like this. This I can take it as a control. Now, this I can take it as a control. Control is nothing but CPU chance given to a program. This is actually a control. Now, from a control, so control is the chance given. Now, from a control, if I take a piece of control, so from this, if I take a small piece, now this is one thread. I can take one more piece. I can take one more piece. These are the threads. Now, why I am taking multiple pieces? So that I can give different jobs to different threads. So the control, in another terms, if I take the control, you can take it as a main thread. Even if you don't create any thread, there will be a thread called main thread. The main thread is nothing but the control available with the program. Control is nothing but CPU chance given. So when I have multiple threads, so there is here I'm giving thread 1. So there is a thread here. There is thread 1, which is given some job. Like suppose if it is if it is suppose starting program, it may be sending some messages. Its job is to send messages. There may be one more thread here. One more thread here, which will be receiving the messages, thread 2. So this job of this thread is receive messages, and there may be one more thread here, third thread. Just example I am giving. There is one more thread present here, which is actually thread 3, which may be taking care of the display, means the view, means it will be displaying the screen and other things. So each thread, say all these things should happen together. So here receiving of messages should happen together, and then sending the messages should happen together, and at the same time this display different the windows should be displayed. So that is generally called as view, and that should also happen together, and for everything there is a thread that will be doing that job. So this is actually the multi-threading, and what is a thread here is nothing but a piece taken from a control. So thread in some terms, what I can take thread as a piece, a small piece of a piece of control. That's why it is called as a thread, piece of control is a thread. Now, what a program does? A program under execution is called as a process. So what process does? It does a job. It performs a job, performs a task. Thread also performs a task. Why then thread is also called as it is also called as a lightweight process. The other definition of thread is it is also called as lightweight process. Lightweight process. Now, what process does? Performs a job. What thread does? It performs a job. So that's why it is kind of a process, and it's not full-fledged process. It's a lightweight process. Now, this is one definition of thread. Now, when I take a process is the one which exists on its own, whereas thread is the one which cannot exist on its own. It should be existing as part of the process. So as part of the process, there will be thread executing, thread present. So like there is when there is a control, there is a process, I can have a thread, and these threads are called as child thread. The process, we can call it as main thread. So the threads, what they do is they do a job within the process, and because they are doing a job like a process, they are also called as lightweight process. Why they are called as lightweight process? Now, when you take a process, the process requires so many resources. When you start running a program, the program demands several resources from the operating system. So if a process needs to be executed, it requires so many resources to continue the execution. It may require several buffers, input buffer, like for reading the data from the keyboard, output buffer to send the data to the monitor. Then there will be buffers related with files. There will be some variables. So every process demands several resources. Even one resource that is required by any process is a stock. There will be heap present, stock present. So all those resources are required. Whereas when you take a thread will not demand new resources. It will start doing new job without demanding much new resources. It may be requiring new stock, but other resources like buffers and all, it will make use of the buffers that are there with the process. So since thread is not demanding new resources, it is not demanding new resources, putting burden on the operating system. So it is called as lightweight. Whereas process demands so many resources, puts burden on the operating system. So process can be treated as heavyweight. So that is the difference between process and thread. Both will be doing the job, and thread is performing a new job within the process. So that's why it does it without demanding much new resources. That's why it is called as lightweight process. So that is about the definition of a thread. Thread is a piece of control which will be taken from the main thread, which is another name for control, and the new thread, whatever given, will be new thread, whatever created, will be given new task. So that is the thread definition. Okay. Now Java is now coming to threads in Java. Java is very efficient in creation of threads. Now you can create threads in Python, but still Python does not have facilities to create full-fledged threads and do the job. It's not still foolproof to create threads and do multiple jobs. But whereas Java has very good library and very good technique to create threads and do multitask. So with respect to threads, Java wins over Python because threads are managed and controlled very efficiently in Java. Now, you know that Java is a object-oriented programming language, and anything is done with the help of classes. So there are two things that are generally associated with the threads. One is thread class. Thread class, it has got so many methods. Another is runnable interface. Now, when you take thread has properties like every thread, whatever created, it is for performing a new job. Thread is associated with a name. It is associated with a priority because when multiple jobs are done, multiple processes or multiple threads are executed, the priority plays an important role. So every thread is associated with some properties like there will be name, there will be priority, there will be group. So you can have group of threads. So there will be groups. So these are the properties. Now, when we take the thread, when we take creation of thread, you can do it. Two things are associated with two classes are associated with thread in Java library. One is thread class, another is runnable interface. You know what is an interface. Now, when you take the thread class, normally if I want to create a thread class, now if I take creation of threads in Java, creation of threads in Java, it can be done in two ways. One is extending the thread class. So I can create a thread by extending thread class. Another is by implementing runnable interface. Now, normally, if I take a class, suppose if I am using a class, I want to create a GUI based classes in Java. So I can take a class called something like a calculator. Suppose if I want to have a calculator, by extending extends what class? JFrame class. That you will be learning in Sphinx. So there is a JFrame to create the windows, and normally we have to extend. If I want to create a window GUI, I must extend JFrame, but there are other ways. But generally we use JFrame. Now here I'm extending this class to create a calculator. I want to create a calculator, but calculator requires GUI. So GUI building GUI on our own is building GUI on our is a complex task. So what we can do is we can reuse the existing called JFrame. So when I use extend the JFrame class, then it is easy for me to create a window. But for this class, I want to have a thread. In this class, I want to have a thread. So when I want to have a thread here, there are two ways. One is extending thread class, another is implementing runnable interface. Now I am already extending JFrame, which is compulsory for me. Now, how can I extend again? Suppose if I take a thread here, extends JFrame and thread, it is an error in Java because you cannot, yesterday we discussed that Java does not support multiple inheritance. Now, in this class, I'm extending an important class JFrame, but I want thread to be incorporated. So instead of going for extending thread class, I can implement runnable interface. So that's how the runnable interface is useful. We'll discuss much about both of the classes. So in situations where you cannot extend thread class, then you can go for runnable interface. You can implement. So either you can use thread class, or you can extend thread class, or you can implement runnable. So these are the two ways. But there is a huge difference between the two. Suppose if I create a class, before I give that, normally when I take a thread, why do we use thread as we discussed here? Why do we use thread to perform a job? So if I take a thread, there will be job, like this is the job, whatever we are giving. So what is the job here? Job of the thread is sending message. And what is the job of this thread? Receiving message. What is the job of the thread 3? Take care of GUI. So every thread has a job. Now, what is the job of how you assign job to the thread? The important thing is there is a run method. So when I take a run method, there is a method called public. There is a method called run, which this signature public void run, there is a method called run. So when I take this run method, whatever code you write here, that will be the job of the thread. So whatever you write here, that will be the job of the thread. So for any thread, if you want to assign a job, define a run method, and then write the code in run method. That will be the job of the thread. So that is very important thing. So whatever job you want to assign, that job must be kept within the run method. So that is the run method. Now, if I take the so the job of the thread will be there in run method. Now, when I take a class, suppose if I take a class like I want to create a class like child thread. I want to create a class called child thread by extending thread class. So when I extend the thread class, then what happens is this class is a full-fledged thread. Now, because I am extending the thread class, whatever facilities that are there in thread class are readily available in child thread class. So it's a full-fledged thread. So there are some methods what you can use, but you can also assign a job, like you can assign job to the thread. So that's what happens there when I extend. So this is actually a full-fledged thread class. It's a full-fledged thread class. So whatever facilities that are there in thread will be available. And there is a run method you need to define, keep it there, and other things are readily available. Now, when I take a class, suppose if I take calculator class calculator, I am extending. It's not necessary that I have to extend another class, but suppose if I'm extending already some class and I'm implementing this implements runnable interface, then in this case, this class, whatever I'm creating, calculator class, is not full-fledged thread, not full-fledged thread class. So now what happens is, when it's not full-fledged thread class, but runnable interface has one method, abstract method, because when I take interface, there will be only abstract methods present in the interface. So only one abstract method that is there here is run. So I can have a run method defined. So because this run method is part of runnable interface, I am forced to define, because when I am implementing any interface or extending abstract class, I must define all the abstract methods, because interface consists of only abstract methods. In runnable interface, there is only one abstract method, run. So I can define the job. So when I'm implementing runnable interface, I have a facility to assign the job. Job can be defined here. I have facility to define the job, but it's not full-fledged thread. So to get the thread facilities, what we can do is create a thread class object. Here. Now create a thread class object, and whatever thread facility you want to have, it will be done through this object only. So you must create a thread class, something like this, some mechanism you have to provide. Thread class object. Here it's a reference, you need to instantiate. Object needs to be created, somewhere created. So there should be a reference, and later thread class object must be created, so that you can make use of the facilities of the thread. So this is how, but in this case, whatever available in this case, because it's a full-fledged thread, all thread facilities are readily available. In this, when I'm implementing runnable interface, it's not full-fledged thread. I need to create a thread class object so that I can make use of the facilities of the thread. But the one thing that is assured is the run method, where you can assign the job of the thread. So that is actually the way to create threads using by extending the thread class and by implementing runnable. Okay, we'll come back to that. Now, I told you that this is also a thread. This is also, when I take this is a thread, and every program is associated with a thread. So now when I take the main thread, it is also a thread, and we'll write a program which makes use of the main thread. So before we see how to create our own thread, then we'll also see the concurrent processing, which is an important thing. So now what I'll do is, I'll not create any child thread. So I'll say public class main thread. I'll name it as main thread. Just I'm giving the name. I can give any name. So when I take this, I'll normally it consists of a main method. So the main method will be executed by main thread. Now I'm not creating the thread, but I require the thread facilities. I will require thread properties. So what I can do here is, when I take this, there is a method called current thread, which is a starting method present in a thread class. So if I say thread dot current thread, what this does is thread dot current thread. This okay? We'll check. So I want to get the this is a starting method. So I'll name it as a main thread. First, I'll check whether the code is correct or not. Till now, whatever I have written. So I'll try to compile this. Okay, sorry. I need to use so current thread. This is, I think it should be okay now. Yeah, the method is current, because Java uses a convention. Methods, when you take, it begins with lowercase letter, and every new word begins with uppercase letter. So that's why I'm able to write the correct. And this is the starting method. So that's why I'm using the thread class. So if I want to call it, call a static method, I don't require an object, but I require the class name. So with the class name thread, I'm able to call current thread, which will give the thread which is executing. So there will be thread which is executing the code, the main thread. That's what I told you. So this is the thread here. When I take this this part, thick line, it's a main thread. It is already executing, and it is executing main. Now I want to get that thread. So how do I get that thread? Whatever this code, whichever thread is executing this code, the main method, whichever thread is executing this method, that thread I'm able to obtain using current thread. And what is that thread? It's a main thread. So it is, now I'll try to print the name of the thread. I told you the thread is associated with a method with a property like name. So the name I can get it with the help of get name. So I'll say main thread dot get name. So the name of the thread is obtained. And if I take priority, you can obtain the priority with the help of get priority. So I'm trying to get the priority. Now I'll execute it. So I'll come back to priority later in a moment. So I'll execute this. So I'll say main thread. So main 5. So the name of the main thread is main. This is the name of the main thread. And what is the priority? 5. Now, when I take the priority of threads, it will be ranging from 1 to, I think it is 1 to 9 or 1 to 10, the priorities. 9 is the highest priority, 1 is the least priority, and 5 is the normal priority. So max priority, min priority, we'll try to get that whether it is available or not. We'll try to check so that we can know what is there. So here I'll say max priority. Now we'll check whether it gives some output or not. So max priority. Sorry, there is no method. It's a very constant. So yeah, it is coming. So similarly, there is min priority. We'll see what are the maximum and minimum priorities, and what is the common priority. So I'll say min priority. They're all static properties, and I think think, okay, we'll try to print them. Now I'll execute. So 10 is the highest priority. It is not 9, 10. So maximum priority is 10 and minimum priority is 1. So maximum the priorities ranges from 1 to 10. So that's what it is giving. So there are constants defined already in thread class. I'm able to get those constant. And what is the normal priority? We'll see whether I can get normal priority with non-priority. I'll check whether it is coming or not. I'm not sure. So it's coming. So normal priority is 5. So this is the normal common priority, default priority. This is the minimum priority, and this is the maximum priority. Now, if you want, we can change the priority. We can change the name and other things. So I can say main thread. I can print directly the thread object. See, one concept here is whenever I print a thread object, any object for that matter, any object directly. What I am doing here, I am trying to print the thread object. When I try to print any object in Java, what it does is it calls toString method of that object. So that is one very important thing. So whenever I want to get some meaningful information, meaningful information when an object is printed, what I need to do is define toString. So when I define toString, whenever an object is printed, it calls the toString. So here also it calls toString. What this does is it prints the name, priority, and group name. So that's what it does. So I'll execute it again. So now when I take this, it is printing the toString. So what is the name of the thread? Main. What is the priority? 5, which is the default priority. What is the group it belongs? It is main. Now, suppose if I want to change the name, so I can say main thread dot set name. I can say hello. Now I can normally priorities should not be changed because it will create problem for operating system because based on priority the operating system execute the process and thread. The highest priority is generally given to system jobs like keyboard reading, all those things will be given the highest priority. Now, suppose if I give the priority as 8, now again I'll try to print here. I've changed the name of the thread and priority, then I'll print. Now the details will be different. So I'll execute this. So after I change the name of the thread and priority are changed to hello and 8. So that's how I can control which thread I'm using, the existing thread. I have not created any child thread. Okay, one more method here for associated with threads. I'll give the other method is we can make the thread get suspended for some time. So that is actually I can say thread dot sleep. Current thread will be suspended for some time. Now I want to suspend it for 1000 milliseconds. It will be huge time, so I think 100 I'll keep. It will be suspended. But the problem is this method generates an exception, checked exception called interrupted exception. So when I try to compile this, it gives error because it generates interrupted exception. So it is saying unreported exception, interrupted exception. So now what is the solution? Either I have to keep it inside try catch, or I can say throws interrupted exception. We discussed this already, throws interrupted exception. So when I do this, now I can execute it. Now what is happening here? So 100 milliseconds is not lengthy time. So what we can do here is I can say I can display a message like thread is getting suspended. Means for some time it is suspended, and after that it will be revoked. Thread is revoked. So now I'll execute this. Now thread is getting, it is taking some time. So I'll give more time here. Suppose if I take 5000 milliseconds, I think 5 seconds, 5000 milliseconds. So now it is waiting for some time. Then it displays revoked. It will take time. So it is you can stop. You can suspend the thread for some period by using sleep. So if you want to use sleep, either it must be kept within try catch or you have to say throws interrupted action. These are some properties of properties and methods of thread class. Now, the important thing when we want to create a thread class, and there is a misconception normally people have with threads is related with the run method. Now, when I take a thread, so we have to create a thread. How do we create thread? By creating an instance of a thread. So here we'll see thread life cycle. So we'll see thread life cycle. So I'll try to define that here. So I'll take one circle. I'll try to draw a circle life cycle, which I'll explain here. I'll take here. I'll try to use a circle. So there is first, when we create a thread, there will be the thread state is called as new state. This is state transition diagram. State transition diagram of thread, or transition diagram of thread, or it is thread life cycle. So when we create an instance of the thread, it is considered as new. Now when you take a thread is like a process. So what actually happens is generally the operating system maintains a queue. So it maintains a queue of threads, queue of process and threads. So this is treated as a ready queue.
Sir, your voice is not audible.
Voice is not audible now?
No, it's audible.
No, I just I'm trying to draw. You are able to see the screen, no?
Yes, sir. Yes.
Okay, here there is a queue. Always queue present, just I'm writing the queue here. So this is a queue called ready queue. It is from this only the microprocessor or operating system picks the threads. So when we create a thread, suppose if I say thread th, so when I say thread th equals to new thread, I'm creating a thread. So when I do this, what happens? A thread is created and it will be in the state of new. So when I do this, then this statement will create a thread, new thread. Now once a thread is created, now our job is to push the thread into ready queue. So there is a so when the thread is in ready queue, then the thread is said to be in ready state. So this is ready state. Ready state means ready to execute. So how a thread from a new thread comes into the ready state is when I do this like start. Thread has got a method called start. Thread has a method called start. So the important thing is many things that when I say start, the thread is going to be executed. But when we say start, thread is not going to be executed. Thread is moved into ready state. Ready state means it is waiting for its turn of CPU. It is waiting for its turn of CPU. And who will then once it is in ready state, based on the priorities and based on where it is present, suppose if it is present at front end, then the thread is picked. And it is under execution. When the thread is under execution, it is said to be in run state. And how it comes to into run state, it's not our job. We cannot move a thread into run state. It is automatically done. So from ready to run, when a thread moves from ready to run it is based on when CPU picks that thread. So that depends upon several things like its priority and other things. So this is not in our hands. It is not in our hands. It is in operating system hands. It is based on the priority. It is based on what algorithm the operating system is using. So here CPU picks the thread. When CPU picks the thread, then only it will go into ready state. So from creation, it will go here, and from new, it will go to the ready state. When it goes to ready state, when start is executed, from ready it will go to run. When it will go to run, only when CPU picks it. It is not in our hands. When CPU picks, it will go into run state. From here it will go to run state. Run state is not in our hands. It is picked by CPU. And what happens when it is in run state? Now, if it is thread, what it is doing is it will be doing run method. It will be executing the run method. In run state, run method is getting executed. There is also one misconception here. I'll give that. Now, when a thread started execution, when a thread starts execution, it is not sure that it will be executed from beginning to end. It is not sure that the thread is executed from beginning to end. It depends on the job of the thread, and what it is doing, all those things, how much time it requires. So from run method, it may go into a suspended state. Yeah, from run method, suppose like I told you, the threads and processes are executed in time sharing mode. When the time allotted for the thread is over, then from run state, it will go back to ready state. Run state, it may go back to ready state when its time slice is over. So here, from here to here, when the allotted time slice is over, T is finished. T is over means time is finished, over. Then it will go back to the ready state and again wait for its turn. Now, this is so from run to ready state, it will go when time slice is over. Now, to run state, it will come in only from only ready state, not from any other state. Okay. Only when CPU picks, it will come. But sometime when it is getting executed, suppose if IO is required, then it will go into the blocked state till IO is finished. Or sleep is executed, it will go into blocked state or suspended state. So there is a suspended state here. This is suspended or blocked. So from suspended state, because of several reasons, it may go to, from run state, because of several reasons, it may go to suspended state. One is when IO is required. When IO is required, it may go into suspended state. When sleep is executed, it may go into suspended state. So because of several reasons, suppose if there is something like there is join method executed, then also it is suspended. So because of several reasons, the thread is going to be suspended. When it is suspended, it will go into suspended state. After the suspension is revoked, suppose sleep time is over, IO is finished, then it cannot come to run state. It has to go to again ready state, compete for CPU with other threads. So from here, it will go to the ready state. From here, it will go to ready state. This is the life cycle of thread. So there are this concept is very important. The important thing is when we say start, we are moving the thread into queue. That's all, ready queue. We are not executing the thread. Okay. From ready queue, when CPU picks the thread, it will enter into run state. In run state, run method is going to be executed. So this is how the thread works. Now, when I take, okay, we'll write a program. Then I'll explain the other concepts which are actually very important. So I'll take, I'll say here, I'll say child threads. I'll create one child thread. Then we'll see multiple child threads. What happens there, we'll see. So child threads. So here I'm removing this main thread. I'm creating new threads. So what I'll do is I'll create a class called child thread. How do we create child thread? There are two ways. Extend thread class. Now here what I'll do, here I'll create a child class constructor. So where suppose if I get a name, now this is because it is full-fledged thread, I can call the base class. So I can say super, I can pass the name. Now what the important thing is the job public void run. Run is the job. So what here we do is just print the numbers. Print. So we'll say here try, because we'll suspend the thread for some time. We'll take a loop, or you can keep inside try. There is no problem. For int I equals to 1, I less than or equals to 5, I plus plus. The job here is to print the numbers. Just system.out. Okay, I'll take one more here. So I'll print the I value. Now I'll make it sleep for some time. So thread dot sleep. So I'll say 1000. Then the loop continues. Now here I need to have interrupted exception. Otherwise, because I cannot use the sleep method. Here I need not do anything. Just leave it empty. Now what I need to do here is I need to create the child thread. So I'll say child thread cth1 new child thread and name. Suppose if I give something like name, I want to give a name. So 1. Now, when a child thread is created, normally what happens is the main thread should be the one which needs to be executed till needs to be there till all child threads complete the job. So to do that, what I can do is I can say cth1.join. What this join method does is it will make the current thread. Current thread means the thread which is executing this code. Which thread is executing the code? The main thread. I'm making the main thread wait for CTH1 to complete the job. So till CTH1 completes the job, main will be suspended. So you can say here, I'll say system.out.println. So here, this main message is printed only after the child thread completes its job. Main will be printed only after the child thread completes this job. So this is how now here what I am doing, I am creating the child thread, and I had to say I had created the child thread. When child thread is created, it is in new state, nothing will happen. So when it is in new state, I need to move it into the queue, cth1.start. When I say cth1.start, then the child thread is moved into the queue, then from queue it is picked. So this is the code. So I'll say Java C, what is the name? Child threads. Have I saved it? Here I should change the name here because the class name child threads. Sorry, Java C child threads. So now Java child. See, child thread is getting executed. After completion of child thread, then main thread will come into picture. So before child thread, here what happens is here main will be under control. Main is doing the job. So println. So I want to print the name of the main thread. So I'll say thread.current thread get name. So I'm printing the name, which is the main thread. So main thread is under job. Now main thread creates the child thread. Then the child thread will take over, because we are suspending the main thread. So main thread creates child thread, and child thread is getting executed. Child thread completes, then it comes back to main is executed. So this is how we create the child thread, okay, using thread class. Now same thing if I want to do with the runnable interfaces, we need to implement runnable in here. Implements runnable in. When we implement runnable interface, then it is not full-fledged thread. So I need to have a thread class, th object. Then I should say th equals to new thread name. I need to execute this. Now, whenever I want thread related thing, I need to depend on. Now, because if I take cth1 is not a thread. So what I need to do, cth1.th, cth1.th. Here I need to say this, the current, whenever I use this, I need to pause this. Now, if I execute this, same thing is happening, but with the help of runnable interface, I am doing. So what is the changes here when I use runnable interfaces? I'm creating a reference to thread. Then that should be instantiated. When you are creating a runnable interface, where the thread method is present, run method is present. So the run method is present in the same class. So that class object I need to pass. So how to refer this current object? Using this. So this indicates that for this thread, the job is there in the current run method of the current class. So that's what it happens. Then because now child thread is not full-fledged thread, so whatever thread method I want to execute, I have to execute through th. So here I'm doing it with through th. So this is the important thing. Now I'm creating the child thread here, child thread 1. Now what happens here? Suppose if I want to get the name of the child thread, so I can get here. I'll say because this is the important concept. I'm going to explain here. Println. This is I'll say thread dot current thread get name. So now if I try to execute here, then try check what is happening there. Now who is here? This is one. What is this? This is when I enter into the child thread, it is the name is 1. So 1 is executed. 1 is the child thread which is getting executed. Now the important thing is, now run method of the thread will be containing the child will be containing the job of the thread. Now, why I need to use start? Can't I execute the run method directly? That is one very important thing. So, instead of start, why I need to start? Because the child thread, I'm creating the child thread, and I can call the run method here, because the job needs to be done. The job is there in run method, it can be done. So this is the important concept. Many will be getting confused. So I must execute start. When I execute start, thread is moved into the queue, and when the thread is picked from the queue, the run method is executed for the thread. So the thread will be doing the job by performing the statements that are there in run method. Okay, now instead of calling start, if I do the run method, if I call directly the run method, what happens? So what happens is here is, now TH will not be doing the job. The main thread itself, now the main thread is doing this job. The main thread is doing this job, not the child thread. So there will be only one thread. Another thread is not sent into the queue. It is not there in the competition. The main thread itself is doing the job. How do I know that? So now here what we got earlier, you can observe, yeah, I'm getting this is one. Now, when I execute the run method directly, see, this is one very important concept. When I execute this method directly, run method, now check what is going to happen. Now you can observe who is executing that job. Run is main, not the child thread. Okay, that is the important thing. The child thread is executing, and now that is the problem. So here main is executing the run method, not the child thread. Now, if I say start, who is executing that run method? It is here you can observe where I have written. So here, when I call start, run method is getting executed by child thread called one. But when I don't say start and when I call the run method directly, when I don't say start and when I call the run method directly, then who is executing the run method? The child thread is created, but not in competition because we have not moved into the queue. The same job is done by the main method. So we should never execute run method directly. If you execute the run method, you can execute. If you want, you can execute. But the problem is the method, the thread which calls the run method will be executing the code, not the child thread which is created. So this is one very important concept that is required here. Now one more thing here is one more concept, one important concept I'll give you, and we'll try to close because it is related with thread synchronization because it is not properly given in textbooks also. Now my job here, I'll create a child thread here. So my job here is I'll extend the thread class so that the code will be much simpler. So I'll say extend. I'll rename this. I want to display the tables. So I'll say tables.java. I want to display some 13 tables, 17 table. So extends the thread class. So I'll remove this. Now here I'll take table ID, int table ID. Now what table ID I want, means which table I want to display. So TID. So I'll say here super name. Okay. Then TID, I'll say table ID equals to TID. Now, what I want here is I want to display the table of the given table ID. So I want to display the table. So I'll display up to 10. Here I'll say print ln table ID. So this is one important thing here related with the concurrent execution. So I'm displaying the table. So I'll say 100 here. So what I'll do, okay, child threads. Now I'll remove all these messages. So child thread 1 because it's created with this. So I'll say this. I'll remove everything. My aim is to display the table. So 1, I'll say 13 tables. So now what is going to happen, we'll see. Sorry, not Java, see tables.java. Okay, here's I need to change this name here, tables, and somewhere some mistakes. Where is the mistake? Here there is plus t I'm getting. So I have to call constructor name. Okay, here I need to declare this int. Okay, it's not TID, table ID. So table ID. I'll print it Java tables. So it is displaying the 13 tables. That's what I want. Now the thing is, if I want to have multiple tables, multiple threads to print different tables. So at the same time, I want to create one more child thread. So CTH2. Now 17 here, 17 table I need to display. So I can, sorry, here I should say start, and I can make both join here to join. Now what happens, you see, I'm trying to execute tables together. Now there is a mess, means mix up. Now you will observe clearly here what is happening. So now 13, 17, they are mixing up, not necessarily in order. Here you are getting in order, but sometimes they get, sometimes same thread will be given 2 times a chance. So here you can observe. So 13 is given 2 times, execution 2 times. 13 is 17, 4. Okay, it is coming here. 13 is getting executed. 13, 9, 13, 10, and 17, 10 also coming. Okay, it is getting executed, but it is messing up. But I want the tables here, the threads to execute in a cooperative way. Means I want first 13 table to be completed, then 17 table. So what I can do here is there is a word called synchronized. There is a synchronized keyword. What this does is synchronized keyword will try to obtain a log before some thread enters into it. After a thread is inside, no other thread is allowed. But that will not work here because I'll explain you the concept synchronized. Because the synchronized will work only when there is a common object they are working. When they are working with common object, then there is a synchronization problem. The synchronization will come. If they are working on an individual objects, then that synchronization will not work. So what I'll do, I'll have a table called class called table. Now here I'll say int. I'll give something like table ID. Okay, I'll say here a table. What I need to have here simply I'll not I'll take okay, display table. I'll say display table, display table. So void display table. I want to display the table here with some table ID, int ti table ID. So what I'll do, that displaying of job, I'll keep it here. I'm keeping the display job here. Table ID, it will be displayed. Now what I'll do here, there is this child thread will be associated with table object and table ID. So I'll create table object TOB, and here table ID TOB equals to TB. TB I'll pass. TB I'll pass as up. Now what I'll do here, I'll use the table object to display. I'll remove synchronized here. Now there is a table object. The table object will display tb dot display table TID, table ID, table ID. Now here I'll create a table object which is common for both. Table TOB new table created. Now that I'll pass it to the child threads where I'm keeping that second. So I'll pass it as a, so TB I'll pass TB. Now what I am doing, the job of performing the table, I'm giving it to one class called table, and it is common for both the child threads. See, I'm creating, there is a table TOB, I'm creating one object, table object, same I'm sharing. So only when they are sharing some data, then they can be synchronized. When they are not sharing, they cannot be synchronized. Now I'll try to execute this. So what it is saying, cannot say, I think TOB. Yeah, it is not TB, TOB. TB, so TOB, display table, thread sleep exception error. So where I'm doing this, this is TOB. Again, this is TOB. And here I'm taking sleep method. So here I should say throws interrupted exception. Now I'll execute this, not child threads, tables. Now there is no error. I'll try to execute. Still you will get same problem. So there is a mess up. Now they are sharing the data. There is a mess up. Now what I'll do is I'll synchronize this method. When I synchronize, now you see what is going to happen. Now you can observe first 13 table will be completed, then 17 tables. So there is a cooperation or communication between the threads. This is actually thread synchronization. So the concurrent execution, the problems come in a concurrent execution only when the data is shared. When there is no sharing of data, there is no question of concurrent execution. That is very important thing. That's why what I have done, I have created a table called table where the job of displaying I am keeping, and this table I am sharing with both the threads. That is the important one. I am sharing with both the threads. Because I am sharing the same object with both threads, now there is a concurrency, concurrent execution. Only when data is shared, there can be a possibility of concurrent execution. Now data is shared, and when they are executed together, then what happens? There will be surely problem. So I'm removing this. When they are executed together, then there is a problem. The problem is there is some mess up in the output. So to avoid that, what I'm doing is I'm using synchronized keyword. What synchronized keyword does is once the first table, whichever it is, enters here, enters into this. What it does is it will obtain the lock. Once a table is, once a thread is has a lock, then no other thread can enter that till that lock is released. So this is thread synchronization, and that will happen only when the data is shared and we have synchronized keyword. So this is how the thread synchronization happens. Is it clear? So that's about thread synchronization. Okay.
Students, you have any doubt? Can ask.
Yeah, if you have any doubt, you can ask. Actually, I think we have discussed sufficient concept. There is one more complex concept called inter-thread communication, but I'm not going to cover it here. But if you have understood whatever I have taught, the synchronization, when the synchronization is applicable, how to apply synchronization, that is enough, because threads is a very important concept. It will be used at multiple places when you are using Java, even when you are doing some advanced programming, like when you are writing web applications, you may have to use threads. So thread is one important concept. If you have any doubt on any concept till now, whatever we have discussed, you can ask.
You can type in the chat box.
Yeah, you can type if you want. I'll check and I'll try to answer. So anybody, please ask some question so that I'll feel happy to answer the question.
See, I'll enable your mic. Please ask, sir. Students, your mics have been enabled. You can ask, sir, any questions you have. The concepts covered yesterday and today.
You can also type if you are hesitant to ask. You can type. I'll not reveal your name. Just I'll see the message and try to answer. You can privately chat. You can send it to only one user. You can send the question to me. If I'll try to answer. I think nobody is asking question among some.
Yeah, they'll ask, sir, generally, but here. Roll number 769, 767, Manite, C1. You can ask questions. Karthik, Dikshita, you can ask some questions if you have any doubts. Sridyuti, 797 are here. You can type in the chat box regarding threads, superclass, or whatever it is, whatever you feel difficult or you want to ask something. Meghana, Rohit, I think they are hesitating, sir, to ask.
Okay, it's okay.
Okay.
Okay. This video is recorded, no?
Yes, sir. The video is recorded.
Later also they can ask. They can send mail or WhatsApp questions. I'll try to answer. They have doubts.
Yes, sir. Sure.
Okay. Shall we close?
Yeah. Some idea about collection classes or swing, sir. If just idea, if you can give. So that's there in the module 4. Just an idea. So
okay. Now, okay. Collection. When you take the collection classes are used to maintain data in an efficient way. So if you want to maintain data in efficient way, group of data items, then we go for collections. And when you take the collections, the important thing with the collections is the collections are they can maintain the data only in the form of objects. Suppose if I want to maintain integers, I cannot maintain in the collection. There are so many collections present, starting from simple array list to table, like hash table, hash map. And when you take the collections, whatever we have learned in Python, the same collections are there. There is for set, there is a hash set. For list, there is a array list. And then for dictionary, there is a hash map. So almost the collections remain same. The list, there is no tuple in Java, but there is a list, there is set, and there is dictionary in the form of hash map. But the thing here is in Python, the collection can maintain the data in the form of standard data types. Even I can say list of integers, or I can have list of strings, which is a object. I can have list of lists. But in Java, you can have only list of objects, collection of objects, not any other collection of objects. So when you have collection of objects, and if you want to represent the standard data items like integers, float, double in the form of collection, then we have to go for wrapper classes. So wrapper classes allow make the standard data items behave like objects. Mainly they are created to make the standard data items part of collections. So that is one thing to note. Now when I take collection, there is an array list. Just one important point I'll give, and array list is one collection and vector is another collection. These are one category. Then there is set, there is no old one, and there is when I take hash table, there is hash, I think hash table is there, and hash table is I think capital H and small t, hash table. And there is a hash map. Now, when I take the array list and vector, both are same. They do the same thing. Hash table and hash map, they do the same thing. But the difference is array list and vector are like lists of Python. Hash table and hash map are like dictionary of Python, where you have to have a key value paired. Now, vector and hash table. So, vector and hash table are considered as traditional classes, traditional or legacy classes, where they are there from the beginning, vector and hash table. Now, when vector is doing the job of list and hash table is doing the job of dictionary, why they have created array list and hash map in the recent addition of the library is, now vector is actually thread safe. So it is same as array list. Array list is thread unsafe. Now we know what is thread. I'll explain what is this. Similarly, when I take hash table, is thread safe, and hash map is thread unsafe. Now, when I take, similarly, when you take one more, when I take string, it is not related with collection, or string can also be treated as collection of characters. String is actually immutable class, but it is not recommended to change the string. There are two classes called string buffer and string builder. They are also they are used to replace strings, but they do the same job. String buffer is the old class which allows the string to get modified. String does not allow the modification of the string. Now again, string buffer and builder. String buffer is the old legacy class. It is there from the beginning. String builder is the recent addition. And again, if I take this is thread safe. These are the pair of classes which are same, and one of them is thread safe, another is thread unsafe. What is this? I'll just explain and we'll stop. Now when I take, I have written a program here. Thread program. Now when I take this program, if I remove this synchronized class, it is a thread unsafe. If I keep synchronized here, then it is thread safe. Now what happens in thread safe? In thread safe, when I use synchronized, only one thread at a time is going to enter and execute. When it is thread unsafe, multiple threads are allowed to execute. So what is thread safe? What is the advantage of thread unsafe is, the advantage of thread unsafe is because there is no locking mechanism. Get lock, unlock mechanism is not there. The thread unsafe classes will be executed faster. Now thread safe classes will be executed slower. That is the main thing. So if I want to build the strings where modification is required and I want to execute quickly, so I need to go for thread unsafe class. I want to create a list and I want to execute it faster. Then I can go for array list. I want to create a dictionary and I want to execute it faster. Then I can go for hash map, because it is there is no locking mechanism. When it is thread unsafe, there is no locking mechanism. But the problem is, whenever you feel that the code is executable by multiple threads, go for thread safe, because the concurrency control is more important than faster. But sometimes what happens is there will not be multiple threads executing the code, but when the are thread safe, even when there are multiple threads are not executing on thread safe, then locking and unlocking is common. Even there is only one thread and executing the code, it has to obtain the lock and it has to release the lock, which takes some time, because it has to interact with the operating system to get the lock, and again to release the lock it has to interact with the operating system. So when you know that multiple threads are going to use the data, then you can go for string buffer, vector and hash table. When you know that only single thread is going to be executing the data, then you can go for string builder, array list and hash map. They will be executing faster. So if no multiple threads, go for thread unsafe classes. When there are multiple threads in your program, then go for thread safe classes, because concurrency control will happen. Because there is a concurrency control, they will not be executed faster. But there our aim is concurrency control, not speed. When there are no multiple threads, having concurrency control and having wasting the time to obtain the lock and unlock is not correct. So we can go for thread unsafe classes. So these are the classes that are very important related with collections like array list, hash map, and hash set. Hash set is like set in Java. There are other classes, but we use these classes very frequently. Main class we use is hash map. Hash map is very frequently used collection because it is key value paid. So when you want to search something based on key, then we can go for hash. So that's about brief introduction about collections. Okay.
Okay, sir. Yeah, one
Any
student
doubt they got? No.
yes, sir. One student asked question, sir.
What is that?
And one more thing, sir. Please, once can you enable your video so that we can take screenshot?
Okay, sure. Lighting is not there. Okay, I'll switch on the light.
Yes, sir.
Now it's okay.
Yeah, now it's visible.
Yeah.
I'll just take one screenshot.
Yeah, sure. Yeah, you said somebody asked doubt. What is that doubt?
Yeah, I'll ask. The doubt was they asked how would we implement a multi-threaded file reader or writer? How would we implement a multi-threaded file reader or writer?
Reader or writer?
Yes, sir.
No, I
Implementation.
didn't understand. Read or write? You want to do read write in a file?
Multi-threaded file.
No, multi-threaded. Okay, where you want to read or write?
And the question was kept like a file reader. I think they are asking about database buffer readers and writers.
No, the thread wherever you want to use, the concept remains same.
Yes, sir.
But when you are sharing the data, then concurrency control should be there. Means if they are writing into the same file, they are writing into the different files, then you can create multiple threads and ask them to do the job without concurrency control. But when they are writing into the same file, then the concurrency control is required. So that is important. So as long as they write it in a different file, there is no sharing happen. Or suppose if they are writing the shared data or reading the shared data from a file, then inter-thread communication is required, which is using notify and wait methods. So
yes,
the important thing is sharing. If there is no sharing of data, sharing of file, they can create the threads as they like normal way, they can execute. But either sharing of data is happening or sharing of file is happening, then they have to go for concurrency control with the help of thread synchronization and inter-thread communication. Inter-thread communication is required like producer consumer. When one is producing, another is consuming, there should be some communication between them. Only after some data is produced, the data needs to be consumed. So for that we require ITC. When there is no sub dependency present, one is producing, another is consuming, no such relationship present, but still they are sharing the data, then they can go for thread synchronization, just thread synchronization. When one is doing and the other one is using that, then along with thread synchronization, they require ITC, inter-thread communication. It is like
okay.
Someone has written question.
Someone has given one more question, sir.
Yeah, what is that? When we rethrow exception using throw, should write the same catch block once again in order to not to get an exception. Will there be any problem if we repeat the same catch block? No, catch block you cannot repeat. See, one catch block with same class can be attached to a try block. If you have one more try block, then within the try block where exception is thrown, then that outside try block can have a catch block with the same name. So there is no problem if you have similar catch block but not attached to the same try block. It is something like that.
Okay.
I'll just you 1 minute. So there is a try block here. I'm calling a method test here. So I'm calling test method where there is a try block again in this. So it will make okay. There is a test method, and here in this I have a try block. And there is a catch block. Series of catch blocks. Now I'm in main here. I'm in main. From main, I have a catch block here. This is actually called as nested catch block. So rethrowing, recatching will happen when it is nesting. Now in this try block, I'm calling test. Now what happens here? It calls test. Some exception is generated. Now there is a catch. This is a catch block which is catching that. From here, if I rethrow, now there is no chance to the catch block associated with this try block. That's what I am saying. If there is no catch catch block is given chance again associated with this try block once it is caught here. Now, if I rethrow here, if I'm rethrowing, I'm rethrowing obj. Now, this thrown object, where it is useful? It is useful here in this catch. For this catch block, it is useful. Not this is a different try block, nested try block. Now, it is not useful to the catch blocks that are here. If there are some catch block followed by this catch block, they cannot get that. They cannot catch the exception. Okay, only this catch block can catch the exception. I hope I answered your question. Okay.
Oh, students, any more doubts in any topic, anything? If you want to ask, you can ask.
No, threat communication will not, there is no question of improving. There will be communication happens that will be done with the help of wait and notify methods. That is only through wait and notify threat communication happens. It is ITC, inter-threat communication, wait and notify. There are methods of threat class. So, inter-thread communication happens with the wait and notify. Other than that, there are no methods. Okay, any other doubt? Think shall we close, Imam sir?
Yeah, yes, sir.
Okay, thank you very much, students, and we'll see. We'll try to meet again if possible. We'll see the other things whenever. Thank you very much.
Thank you, sir. Thank you so much for sharing knowledge and gain for improvement of students, sir.